Welcome to another deep dive. You're here because you want to get smart fast, and that's exactly what we're about.
That's the goal.
Today, we're strapping in for a look at the early days of a truly legendary machine, the F-16 Fighting Falcon.
Yep. We'll explore its pretty groundbreaking beginnings and some of those key early moments where it really proved its mettle in combat.
Okay. And to really get a handle on the F-16's impact, we've pulled together some great sources.
We have articles from Code One magazine, which is fantastic, insights straight from Lockheed Martin, and some good overviews from Simple Flying, too.
So the solid mix.
Yeah, these really give us a detailed picture, how this aircraft came about and the initial mark it made.
Okay, so the F-16, it wasn't just like born in a vacuum, right? Its story really kicks off with a hard look at air combat realities in Vietnam.
Exactly. The U.S. Air Force, they realized their fighter effectiveness against these nimble adversaries like the MiG-17, the MiG-21. It just wasn't what it used to be.
And the numbers show it, don't they?
Oh, absolutely. What's fascinating is if you compare it to the Korean War, back then, the combat exchange ratio was, what, around 10 to 1?
10 enemy aircraft lost for every one U.S. loss. Pretty dominant.
Totally.
Yeah,
But
yeah.
jump forward to 1965 in Vietnam, and that ratio had dropped a lot, down to about 3.3 to 1.
Wow.
And later, it got even tighter, sometimes dipping down to like 1.5 to 1, which definitely raised some serious questions back at the Pentagon.
Yeah, you'd think so. And a big part of that shift, as I understand it, was this growing reliance on early air-to-air missiles.
That was a major factor. The thinking was all about beyond visual range, shoot first from a distance.
But the reality on the ground, or in the air, rather.
Exactly. Pilots kept finding themselves in these close-in dogfights where maneuverability, pure agility was still absolutely king. The Air Force knew they needed something different.
So that leads us to the Advanced Day Fighter Program, ADF.
Precisely. The ADF program, the goal there was to create a fighter, maybe around 25,000 pounds, that would really outperform the MiG-21. They were looking for a big edge in thrust to weight and wing loading.
And right around this time, this visionary figure emerges, Colonel John Boyd.
Ah, Boyd, yes. His energy maneuverability theory, or EM theory, was just revolutionary.
Explain that a bit, in a nutshell.
Okay, so in simple terms, it basically said that a fighter jet that could gain or lose energy, meaning speed and altitude, faster and more efficiently than its opponent, well, that fighter would always have the advantage in a turning fight.
So it's not just about top speed.
Not at all. It's about transitions.
Yeah.
And his theory heavily favored smaller, lighter, more agile aircraft designs.
Okay, so you connect Boyd's ideas, the ADF program's goals, and
You can really see the path being paved for the lightweight fighter program, the LWF.
a step further then.
Yeah, an even bolder step towards designing a smaller aircraft specifically for that superior combat maneuverability.
Now, there was also a strategic angle here too, wasn't there? The LWF wasn't supposed to replace everything.
No, definitely not. It was never intended to be the only fighter. The plan was for it to work alongside the bigger, more complex, very capable McDonnell Douglas F-15 Eagle, which was being developed concurrently.
Like a high-low mix.
Exactly that concept, a force multiplier. Different aircraft bringing different strengths to the fight.
So the LWF program itself, what were the main objectives they laid out?
They were actually very clear. The absolute top priority was maximum usable maneuverability and agility, specifically for air-to-air combat.
Within a certain range.
Yeah, within about a 500 nautical mile radius of its base. But, and this is key, it had to be achieved while keeping a close eye on cost, complexity, and just how easy it would be to maintain and operate.
So performance, but affordable performance.
Right. The emphasis was really on small size, low weight, keeping costs down, and incorporating, cutting-edge technologies and really smart aerodynamic innovations.
Okay, so the Air Force decides to move forward. How did they kick things off?
They moved pretty fast, actually. The request for proposals, the RFP for the LWF, went out to 9 big aerospace companies on January 6, 1972.
9 companies, wow. And the RFP itself was interesting, wasn't it? Quite short.
Very concise, yeah. Only 21 pages, which is tiny for this kind of thing. It really zeroed in on hitting specific performance goals and cost targets rather than laying out this huge, long list of traditional military specs.
Sort of results-oriented.
You could say that. And what's also notable is how tight the leash was on the proposals themselves.
How so?
Each company got just 50 pages. That's it. To describe their aircraft design and the whole test program. plus another 10 pages for cost and management stuff.
That's not much space.
Not at all. And they even had to submit wind tunnel data and a scale model really early in the process. It made that initial competition almost feel like a wind tunnel shootout, as some called it.
Just based on the projected performance data, okay, what were the core requirements they were asking for?
Pretty ambitious stuff. High thrust-to-weight ratio, obviously, for acceleration and climb.
Wow.
Excellent handling, especially around transonic speeds, the sound barrier region.
Crucial for combat.
Absolutely. They wanted simple avionics and fire control systems, nothing too gold-plated. The airframe needed to handle at least 6.5 Gs.
Standard for fighters.
Right. A suggested gross weight, around 20,000 pounds, so definitely lightweight. And maybe the biggest hurdle, a target unit flyaway cost of just $3 million.
$3 million.
In 1972 dollars, mind you. And that was based on buying 300 aircraft at a rate of 100 per year. Still, incredibly cheap even then.
Wow. Okay, so 9 companies got the RFP. Who actually threw their hat in the ring?
5 companies ended up submitting proposals. You had Boeing, General Dynamics, Lockheed, Northrop, and Vought.
The heavy hitters.
Pretty much. When the initial proposals were analyzed, this was February 18, 1972. Boeing's design, the Model 908, 909, actually came out on top initially.
Oh, okay.
General Dynamics Model 401 was ranked a close second, and Northrop's entry, the twin-engine Model P600, was third.
But that wasn't the final lineup for the fly-off, was it?
No, the Source Selection Authority, the group making the recommendation, they looked at it a bit differently. On March 18th, they ranked General Dynamics first.
Ah, the Model 401.
Yep. Northrop second with the P600, and Boeing slipped to third.
Why the change, and why select 2?
Well, here's where it gets interesting. The General Dynamics design and the Boeing design actually shared some similarities in their approach.
Okay.
So to really explore different technological avenues, different design philosophies, and frankly, to get the most learning out of the whole program, the decision was made to award contracts to build prototypes to both General Dynamics and Northrop.
So they could compare 2 quite different approaches head-to-head.
Exactly. Validate those emerging technologies on 2 distinct airframes.
Makes sense. So who gave the final go-ahead?
That was Air Force Secretary Robert Seamans. He approved the plan to proceed with building prototypes from both GD and Northrop.
And the contracts followed.
Yep, signed in April 1972. General Dynamics got about $37.9 million for 2 of their Model 401 prototypes. Northrop got slightly more, $39.8 million, for their 2 Model 600s.
Because of the twin engines, presumably?
That was the main reason for the cost difference, yeah. 2 engines cost more than 1.
So the main goal now is to build these planes and fly them off against each other.
Right. The primary test objective was crystal clear. Determine the actual operational usefulness of this lightweight fighter concept and figure out which of the advanced technologies each company was bringing to the table really worked best.
Did the companies have free rein?
In terms of design, yes, largely. But the Air Force kept very tight control over the testing and evaluation phase itself.
How did they manage that?
They set up these joint test teams for both aircraft, what would become the YF-16 and the YF-17. These teams were a mix of experts.
From where?
You had people from the contractors themselves, naturally, but also from the Air Force Flight Test Center at Edwards, Tactical Air Command, the eventual users, NASA brought their expertise, and the Air Force Test and Evaluation Center, a real brain trust.
A collaborative effort to get the best data.
Definitely.
Okay, let's zero in on the General Dynamics Model 401, the one that became the F-16.
Right, the YF-16 as it was known internally at GD. This aircraft wasn't just dreamt up overnight. It was really the culmination of years of work, studies involving key figures we mentioned like John Boyd, another proponent, Colonel Everest Riccioni, and crucially, General Dynamics' own Harry Hilliker.
Hilliker. He was a big champion of this lightweight idea, wasn't he?
A huge advocate. His core design philosophy was all about the, quote, prudent application of integrated advanced technologies.
Meaning?
Meaning using new tech smartly to get high performance without driving up complexity and cost unnecessarily. For Hilliker, keeping the aircraft small and light was absolutely central to maximizing its combat capability.
What were some of those key design elements they integrated?
Several really innovative things for the time. A bottom-mounted air intake under the fuselage
Why there?
helps maintain smooth airflow to the engine, even at very high angles of attack, which is critical for maneuverability. Then there was the wing body blending.
Making the wings sort of flow into the fuselage?
Exactly. Creates more lift, reduces drag. They also use variable camber wings, the shape could change slightly, and a single large vertical tail for stability. all focused on performance.
And the single engine was a big part of that low-weight goal.
Oh, huge. The analysis showed that for the required 500-millimeter radius mission, a single-engine configuration like the YF-16 would be nearly 4,500 pounds lighter than a comparable twin-engine design like the YF-17. That's a massive difference.
Significant. Now, you hear sometimes that small planes mean less range. Was that a concern?
It was a common misconception, yeah. But the YF-16 flight evaluation actually proved that wrong. It demonstrated better specific range.
Meaning how far it flies per pound of fuel?
Precisely. Better specific range and a higher fuel fraction, meaning more of its weight was fuel compared to even larger established fighters like the F-15A and the F-4E Phantom.
So small didn't mean short-legged.
Not in this case. The design was just very efficient.
Let's talk more about those advanced technologies. What else was packed into the YF-16?
Okay, well, beyond the blended wing body, they use something called controlled vortex flow.
Sounds complex.
It involves using those sharp leading-edge extensions. The strakes you see running from the wing went forward along the fuselage. They generate these powerful swirling vortices of air over the wing at high angles of attack.
And that helps.
Tremendously. It increases usable lift dramatically and helps maintain control during really aggressive maneuvers. It's like managing the airflow to keep the wing flying when it would normally stall.
Clever. What else?
Automatic variable camber on the wings. Little flaps on the leading edge would automatically adjust based on airspeed and angle of attack.
Optimizing the wing shape constantly.
Yep, keeping the wing working at peak efficiency across different flight regimes. But maybe the single most revolutionary piece of tech was the flight control system.
That fly-by-wire.
The all-electronic, quadruply redundant fly-by-wire system. First time on a fighter like this. No more direct mechanical linkages, cables, pulleys, push rods connecting the pilot's stick and rudder pedals to the control surfaces.
It's all signals down wires.
Right, electronic signals. This allowed for a huge boost in responsiveness and agility. And it enabled another key design feature, relaxed static stability.
Meaning the plane is naturally a bit unstable.
Exactly. Intentionally designed to be slightly unstable longitudinally. A traditional aircraft is designed to want to fly straight and level on its own. The YF-16 wasn't.
Why do that? Seems counterintuitive.
Because that inherent stability creates drag. The tail has to constantly work to keep it stable. By relaxing the stability, the flight control computer makes constant tiny adjustments to keep it flying right, but you reduce that inherent drag.
And that makes it more maneuverable.
And more efficient, yeah. It's a bit like riding a bicycle. It's inherently unstable, but that instability is what allows you to turn and maneuver it so easily. The computer provides the balance.
Fascinating. They really did their homework.
Oh, yeah. General Dynamics analyzed something like 78 different configuration variables. They put in over 1,200 hours of wind tunnel testing, just refining the shape and the integration of all these systems. They definitely left no stone unturned.
And all this tech integration, it paid off in weight savings.
Big time. They calculated it was equivalent to about a 10% reduction in the basic airframe weight compared to a more conventional design trying to achieve the same performance.
And less weight means?
Less weight means lower cost to build, lower cost to operate, and a lighter overall mission weight, which circles back to better performance and efficiency. It's a virtuous cycle.
Okay, so the contract was signed April 72. How long did it actually take to build these prototypes?
Remarkably quick. Just 21 months from contract signing to having the first prototype ready.
That's fast for a cutting-edge fighter.
Extremely fast. The first YF-16, serial number 72 on Force 77, had its formal taxi-out ceremony on December 13, 1973.
And the first flight?
Well, there's a bit of an unexpected turn of events there.
Oh.
The first time it actually left the ground was unintentional.
Yeah.
January 20th, 1974, during a high-speed taxi test with test pilot Phil Ostricher at the controls.
What happened?
It developed this roll oscillation, got a bit squirrely, and Ostricher decided the safest thing was to actually lift off briefly, fly around, and land it, rather than risk crashing it on the runway.
Wow. Talk about an unplanned first flight.
Exactly. The official planned first flight happened shortly after, on February 2nd, 1974.
And the competitor, the Northrop YF-17.
It rolled out a bit later in April 1974 and made its first flight in June of that year. So the YF-16 had a head start in the flight testing.
How did the flight test program go?
It was pretty extensive, ran through most of 1974. The two YF-16 prototypes flew a combined 330 missions, logging about 417 flight hours.
And the YF-17s?
They flew 268 flights, accumulating around 324 hours in the air. The whole competitive fly-off wrapped up in December 1974.
And what was the verdict from the pilots and testers?
Well, according to Lieutenant General William Evans, who oversaw the testing, the results were pretty decisive right from the start,
In favor of?
in favor of the YF-16. His assessment was that it consistently outperformed the YF-17, showed superior maneuver energy, better dash speed, tighter turning rates, and just overall better handling qualities.
So it lived up to the promise of the design,
It really seemed to.
which led to the final decision.
Yep. On January 13, 1975, the Air Force officially announced the YF-16 as the winner of the lightweight fighter competition.
And the justification.
Secretary of Defense James Schlesinger famously put it quite well. He noted it was a, quote, happy circumstance that the airplane with the best performance is also the lowest cost.
Can't argue with that. A true win-win for the Air Force.
Absolutely. Paved the way for the production F-16.
Okay, let's shift gears now. The F-16 enters service. Let's talk about it in action, some of its early war wins.
Right. And while its official name is the Fighting Falcon, it very quickly picked up that nickname Viper among pilots. Still sticks today.
Good to know. Now, chronologically, the Israeli Air Force actually used it in combat first, right? The Osirak raid in '81.
That's correct. But our focus today, as you said, is on its service with the U.S. military.
So where did the U.S. F-16 first see major action?
That would be Operation Desert Storm, the liberation of Kuwait in 1991.
And it's interesting, back then it was still technically a General Dynamics product, wasn't it?
Good point. Lockheed, later Lockheed Martin, didn't acquire the F-16 program from GD until 1993. So yeah, during Desert Storm, they were GD F-16s.
How heavily were they used?
Extensively. USAF F-16s flew an absolutely astonishing number of sorties, 13,340.
13,000, more than any other plane.
More than any other single aircraft type in the coalition inventory. Their primary role was ground attack.
Hitting what kinds of targets?
Key Iraqi infrastructure. Things like airfields, military production facilities, command centers, and importantly, hunting those mobile Scud missile launchers. That high sortie rate really showed its workhorse capability.
Were there losses?
Sadly, yes. 7 S-16s were lost during Desert Storm. 3 of those were confirmed losses due to enemy action.
What took them down?
One was hit by a shoulder-fired SA-16 missile, an IGLA. The other 2 were downed by radar-guided surface-to-air missiles, likely SA-6s or maybe SA-3s.
Yeah.
Air defense was still a threat.
Right, but the F-16's first air-to-air kill in U.S. service came a bit later.
Correct. That happened during Operation Southern Watch, the enforcement of the no-fly zone over southern Iraq after Desert Storm.
When was this?
December 27, 1992. The pilot was then Captain Gary Nordo North, flying a 2-seat F-16D model,
And the adversary?
an Iraqi MiG-25 Foxbat. It had flown south, violating the no-fly zone, and crucially, it was armed with AA-6 Acrid air-to-air missiles. It looked like it was heading towards coalition aircraft.
So North engaged.
He did. He fired an AIM-120 ARAM missile, advanced medium-range air-to-air missile, nicknamed the Slammer.
Yeah.
Direct hit, shot down the MiG-25. This was hugely significant.
Why particularly?
Well, it was the very first air-to-air kill for any U.S. F-16.
Hmm.
And it was also the very first combat kill for the brand-new AMRAAM missile itself. A double first.
And taking down a Foxbat, that's no small feat, right? Those things are fast.
Incredibly fast. The MiG-25 was literally the fastest operational fighter jet ever designed at that point.
Yeah.
So yeah, an F-16 bagging one was a pretty big deal, validating both the jet and its new missile.
Okay, so first kill over Iraq. Where else did the F-16 demonstrate its air-to-air capabilities early on?
The Balkans.
Mm.
Specifically during operations over Bosnia in the mid-90s.
Operation Deny Flight.
That's the one. Established in '93 to enforce a UN no-fly zone over Bosnia and Herzegovina and also provide close air support if needed.
And the F-16s were involved in a specific incident there?
Yes, the Banja Luka incident in February 1994. F-16s from the 526th Fighter Squadron, the Black Knights, based out of Aviano, Italy, were on patrol.
What?
They detected unidentified radar contacts heading into the no-fly zone. These were eventually identified as Bosnian Serb aircraft, specifically 4 Soko J-21 Jastribs and 2 Soko J-22 Araos. Ground attack jets.
Doing what?
They were on a bombing mission, actually attacking a Bosnian munitions factory near Novi Travnik. They ignored repeated warnings from NATO AWACS aircraft to leave the area or land.
So the F-16s intercepted?
They did. This actually became the very first combat engagement, the first wartime action in NATO's entire history.
Really? Wow. And how did it play out?
Captain Robert G. Wilbur Wright engaged first. He shot down 3 of the J-21 Jastribs in quick succession.
3? How?
Use an AIM-120 ARAM for the first kill, and then switch to AIM-9M Sidewinder heat-seeking missiles for the next two. An incredible display of piloting.
Amazing. Were other pilots involved?
Yes. Captain Scott Zulu O'Grady, who later famously was shot down himself, actually damaged another one of the Serb aircraft with a missile, though it apparently managed to escape. And then Captain Steve Yogi Allen engaged and shot down a fourth Yastrib, also using a Sidewinder.
So 4 confirmed kills in 1 engagement for the F-16s?
4 confirmed kills, plus another damaged. A fifth Serb aircraft actually crashed while trying to escape at low level. So overall, the Bosnian Serbs lost 5 jets in that single incident. 3 pilots were killed, 1 wounded.
A decisive outcome.
Absolutely. It starkly demonstrated the F-16's capability as an effective interceptor for enforcing no-fly zones, and it was a huge moment for NATO.
Did the F-16s see more air-to-air action in the Balkans?
It did. Later on, during Operation Allied Force, the NATO bombing campaign over Kosovo and Serbia in 1999.
Any specific kills then?
Yes. On May 4th, 1999, a USAF F-16 shot down a Yugoslav MiG-29 Fulcrum using an AMRAAM. Sadly, the pilot, the Lieutenant Colonel Milenko Pavlovich, who was the commander of the Yugoslav squadron, was killed.
And were any F-16s lost in air combat during Allied force?
It's important to note, no. Despite numerous engagements and a dangerous air defense environment, no F-16s were lost in air-to-air combat during that campaign. Several were lost to ground fire, but none in dogfights.
Shows its survivability, too.
It does. And even later, fast forward to Operation Iraqi Freedom in 2003, there was a sort of poignant reminder of the F-16's long service.
What was that?
During the invasion, U.S. forces actually recovered the canopy from an F-16C tail number 870257 that had been shot down way back during that big Package Q strike deep into Iraq in 1991 during Desert Storm.
Finding a piece of wreckage from 12 years earlier.
Yeah, it just served as this tangible link, showing the F-16's continued presence and relevance across multiple conflicts in the region.
So, wrapping this up then, it's quite a journey we've traced.
It really is. You see the F-16 go from this revolutionary lightweight fighter concept born out of hard lessons learned in Vietnam.
Designed specifically to win the turning fight.
Exactly. And then evolving into this incredibly versatile combat-proven aircraft, achieving these significant early war wins in very different environments over the Persian Gulf and the Balkans.
So hopefully you listening now have a much deeper understanding of the F-16's origins, its initial design philosophy, and some of those really crucial moments that defined its early operational career and built its reputation.
It set the stage for decades of service that continue even today.
Absolutely. And hey, if you found this deep dive informative, maybe learned something new, please do take just a second to hit that like button and subscribe to the channel.
It genuinely helps us keep digging into these topics and bringing these stories to you.
It really does. And as always, we like to leave you with a final thought to chew on.
Okay, so consider this. Given that the F-16 started with such a laser focus on lightweight agility and keeping costs down, how did it manage to evolve over time to take on such an incredibly diverse range of missions, ground attack, SEA reconnaissance, and remain a frontline fighter for so many air forces for so many decades?
Yeah, what does that adaptability tell us about the strength and foresight of that original design by Hilliker and the team? And maybe what does it tell us about the changing nature of aerial warfare itself, demanding that kind of flexibility?
Something to think about.